Logistically, we are here at our work day. That is kind of a continuation of Friday, which Friday got a little haphazard at the end, but we got up to the boards. We practiced 4.7. You were supposed to take what you did on the boards to finish 4.7. I feel like I should start coming up with something to do with those people that the day of, after multiple days of working on it, because you had Wednesday, you had Thursday, you had Friday, we did board work, and then you still haven't even started the homework. I just looked at it and I know who you are. Shame on you. But coming back, we do have a test on Friday. We do have a forever quiz on Wednesday. And we have the test review bonus practice test workday Wednesday. Today was for us talking and finishing up integration as net change, and maybe a question or two from 4.7. So what we're looking at is a couple different things. In your Google Classroom, 4.7 is normal, right? However, we do also have Chapter 4B, where'd it go? Here it is. In like AP review, we have a handout that I gave you with lots of different problems. Okay, this is what's due after the test. This is what's due after the weekend, which is like next Tuesday, because it's an AB minimum day week next week. This is what's due next Tuesday after the test. We're just going to look at number 3 together really quickly. However, because there is one of these problems on the actual test, not quite as intense as some of this that's on the worksheet, but because there is a little bit on the test itself, and it was supposed to be the end of our notes, we do have the CalcAB as integration as net change practice that you guys were supposed to be working on this weekend to get an introduction to all of this. Okay? Some of you have done it, some of you have not. It's due by 11:59. This was our last topic of Chapter 4B. Along those lines, we do have an integration as net change Jamboard that has like the little bit that I put down on Friday about what the key ideas are as or for integration as net change. But we also actually, and many of you have already written it down, we actually also have a forever card, don't we? Those of you that were using the Jamboard to write down your forever cards, we do have forever number, is it 40 or 41? That at one point was earlier, and then I moved it to be later. So it's not so much, is it your most recent card, as the question, is it in your card somewhere? Here's the integration as net change forever card. I can take a copy of it, I can put it in the Jamboard itself. There are a couple different places that we're talking about integration as net change. I gave you one type of summary on Friday. Here's the forever card summary that's been chilling in some of your guys' forever cards for a while now. And we're just doing a little bit of practice. So, Josh, does that answer your question? We have the CalcAB like intro, and then we have like the AP practice that's due after the test. Is that cool? Okay. So those are like the delineation between the two. So, as we get ready to go talk about the CalcAB activity, go talk about 4.7, and just have today be a, are you all on the same page and you can finish these by tonight. Does that make sense? Okay. We're just starting with number 3. Calculators out, definitely. Calculators out. This is number 3 from the AP practice due after the test, just for me to have us all start brand new and fresh on a worksheet. What's the idea of integration as net change? You can look at mine, or you can look at your worksheet. You should be in your notes, and for your notes, you should have made a section, integration as net change. So for the note check on Friday, I will be seeing if you've written down the key information on integration as net change. Doesn't have to have the examples, because those are technically in like your homework spiral. But it does need to have the key information. If we were talking about motion, we have displacement versus total distance traveled versus current position, but we would be using like V for velocity. If we're talking about some other situation, we can think about whatever the rate is. The rate is what goes in those spots. And Q for quantity could be what we're solving for. So in motion, it would be velocity and position, but in others, it could be whatever the rate is and whatever the quantity is. There's a forever card that's kind of similar. If you want a final position, start with the initial and add the displacement. If you want the final amount of something, start with the initial amount and add the change. And integration as net change. The integral of the rate between two times tells me how much it has changed. So check out number 3. What does it tell me about how the tank starts off? The tank starts off with what? You see it? So this could be my initial amount. Now, what do you guys want to call the amount? We could say A for amount. We can say G for gallons, W for water, or just Q for quantity. What do you want to name it? W for water. Okay. So initial, the water that the tank is holding at 0 is 81.637. Is there anything magical about W? Absolutely not. It's a letter that we can use. Is that cool? Okay. What does it say about what happens in the 6 minutes that follows? So this would be my R of T, right? Great news is that there's a decimal, which means we're totally going to our calculator for everything, including finding the integral, which is gorgeous, right? But we have to first figure out what are they actually asking. So kiddos, what's part A asking? Those are the words. So who can write it or explain what it means mathematically? Find what? What expression am I trying to solve? Plug in 4 to what? The rate. I want R of 4. Is that something that my calculator can do?
Yes.
Heck to the yes. Although, if I'm going to maybe use this R multiple times, where's a place I can put it in my calculator and get it again and again and again? Right? I can put it here. I don't want to use the stove button until I have something, right? But I can put any equation that I want here. You guys tracking? Are we all in mode and we're all in radian mode, ready to put it in? Oh, why don't you have your calculators in class? It's like teaching you to drive and you don't have a car. Sign up. It's like, hold the steering wheel. Now pretend. Okay, no. Get your calculators out. Let's go. We have T plus 1. You guys okay? Are we good? If I want to plug something into this, how can I do that on the home screen? I'm just trying to model a very good technique to use on long answers where you have one equation that you're using over and over and over again. How do I plug in something? Alpha trace lets me get the name. Do you see it? Remember? And then F of, isn't that denoted by a parenthesis? Are we okay? Alpha trace, let me get the Y1, parenthesis, and I can say plug in 4, dun, 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 woohoo! This is a problem on the AP exam that they would give you only 1 point for right or wrong. Maybe 2 for units, but probably more, 1 point for getting it right, and then you would get a point off somewhere else for not having the units correct in all of the answers. There is no work to be shown. Absolutely none. All that they want to see is that you know how to plug in, and the final answer would be 7.081. Always 3 decimals. Always 3 decimals. Always how many? 3 what? How often at a time? There you go. But what are the units? Keep looking. Gallons is part of it. You see it? Because I'm doing the rate, I'm finding out how fast, so therefore I'm going to have, is it okay? Gallons per. You just got to keep your bearings. Keep remembering what you're doing. But, are we done with A? Yeah, we are. So what's B? What's B? And all of a sudden, I have to come up here and I have to take this W and say, whoops.
Wouldn't it just be the equation on the forever card?
Yeah. But with a W instead, right? Actually, I might have been okay with that W. Let's see. Because the equation on the forever card would say final amount. I could pull it up. Is it here? Yeah. But instead of using an F of B, what am I going to use instead? W of T, right? So the amount at B, well, the amount of water at some time T is equal to, was there water to begin with? The answer is yes. So what do I have to do before my integral? The initial amount, which is 81.637 plus, you guys seeing it? The amount of water that's in the tank is the amount of water that started being in the tank plus integral. What does the A stand for? Initial. What's the initial? What's the beginning of this problem? 0. In another problem, it might be 9 a.m. where the hours are how many hours from midnight, so it might be a 9 instead. But this one's 0. And then where am I ending? Good. They don't tell me. Good. So I don't know. Maybe 6, maybe 4, maybe 3, maybe 2. I don't know.
How come you're starting from 0?
Because that's the beginning of my situation, and that's the amount that I knew. I don't know any other initial amount besides the one at 0. If I knew a different one, I'd use a different beginning, but I don't. So I won't. What's going to go inside F prime? So do I put W prime? Or do I have something better based on what I've already done? W prime is the same thing as the water's what? Flow rate. And what have I already called that? I've already called it R. Do you see it? And the great thing about AP FRQs is if you've named something, you don't need to keep writing it over and over again. Just call it by name. Which is why in the slides that I showed, one of them, the forever card, says, hey, you can think about his derivative. The other one, like I literally wrote out just, hey, if R is rate. Does that make sense?
Yeah.
But R should be Q prime. Yeah. So you can think about it as, hey, it's his prime, but more often than not, they just give us something like this and they say, that's the rate. We're like, okay, cool. And you just know to put it in the integral. So then what are they trying to ask us for letter C to do? What do I want to find? The water at 6, right? And what am I going to be using to get there? They had me build, yeah, exactly what I needed, right? So I'm just going to go ahead and do my 81.637, and now you can tell me where to stop. 0 to what? You want to know what happened in those 6 minutes, and how you're going to know what happened? You integrate the rate. And then what can you use your calculator for? Everything, exactly. So I can do 81.637, double, triple, quadruple check that you are writing the number that they have written down. It's so easy to make a mistake. Don't look at what you wrote down, look at what they wrote down. Got it. How do I do an integral again? Worst comes to worst, just go math down, 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 down until you get to the one that says INT. But there is a shortcut, and the shortcut is second over takes you to the end. Alpha window has a nice little integral. Ready for you in number 4. My beginning is 0. My ending is 6. And where's my equation? Hanging out, waiting for me to use them? Alpha, trace, y1. I already wrote them down, already used them. Ready to go. Boom. Dun, 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 dun. How many decimal places? How often? Good. 126.668. What are your units? Gallons per minute or gallons?
Gallons.
Because it's
Gallons.
how much water you've come back from the rates. When you integrated, area under the curve told you the change in. The change in what? The change in gallons, which is what makes integration so powerful. I can know the how fast and I can find the how much. Realistically speaking, how much work did that take? Not that much. Conceptually, how deep was it? Pretty deep. You had to know about rates, you had to know about integrals, you had to know about, but how much work did it take? These are the golden problems of the AP, because the time that it takes to do them is minimal as long as you understand the idea. Now, minimal time to do it, maximal understanding of an idea. Section 4.7 was a little bit different, right? Section 4.7, how complicated were the ideas? There are rules, use them. There wasn't a lot of depth to the ideas. It was like, there are rules, use them. However, the by-hand work got a little intense. I do have 4.7 WebAssign open. I am going to the end of the Jamboard where it's like, hey, we were just doing, oh, did you guys notice that I did number 11? I started it for you. And if you watch the video that I posted, I finished it on the next slide. And I started number 12 and got it up to a ... And I did all of number 16 for you. Well, no, but all of the number 16 when it got really, really rough at the air resistance part. If anybody did not, check out what I posted on the stream because you've turned off all of your notifications. Well, watch it before tonight because I'm not doing number 16 in class today. Lucas and I already did it, and then I redid it on a video for you all to access and look at as you need. Any other questions besides number 16, air resistance, and besides number 11? I'm open and available on 4.7 for any questions besides 16. There's a video after the air resistance part, so maybe a person has a question on the beginning of 16. And no questions on number 11 because I did the first part, and for those of you that realize trapezoidal rules say what? I also have in the Jamboard how to keep going with the trapezoidal rule. Yeah. Getting to the end where I actually have space. Anything else besides number 20? 12. Was it 12? Yeah. Sorry. You're like, oh no, I thought. Wasn't 16 the last one? Yeah. That's why I was freaking out. That's the end. Number 12. 12, I think I only started on the Jamboard, and I didn't have it in the recording at all. Anything else besides number 12? Going once? Anything else besides number 12 going twice? Sold to the lady in the second row. Yeah, 4.7. 11's already done in the Jamboard. I started it on Friday, and I finished it in the trapezoidal rule, and I referenced it in the video. Okay, so number 12, which is a lot like 11. Number 12, which is a lot like 11. I would ponder, first of all, P.S. I do have some hints written out on number 12 already if you haven't noticed them. If you want to come back and look at another version. But here's one version of me getting you going on number 12. They do hint that I should complete the square. However, I disagree with completing the square being necessary for everything. Because if I just made u the 4x minus x squared, using a process that we affectionately call u sub, it's like I'm almost good with that numerator. What do I mean by almost good with that numerator? If you want to look at this a different way, I could go ahead and pull out a negative and I would have 2x minus 4. How am I almost good on the numerator? I have a 2x, I have a minus, but I have a, I want a 4, but I have a, so what can I do creatively to fix this problem? If I subtract 1 and add 1, have I thrown it off balance? No. And now all of a sudden I have a 2x minus 4 over this guy. what I have, a negative du over 2x minus 4. But that's only the first part, guys. What else do I have besides 2x minus 4? If I put a minus 1, there's my 2x minus 4, and that's gorgeous for this. But then I have something else. What else is there besides 2x minus 4? What about him? 2x minus 3 minus 1 is 2x minus 4. That's this guy. But what about this guy? What? No. How did she get x minus 2? What am I seeing in that denominator?
0.
Not a 0. This guy's already been dealt with, so it's not that 2. What am I seeing down here in the denominator? What do I do with or when completing the square and looking at the middle term? Do you remember? I divide by 2. What's 4 divided by 2? I'm seeing what I'm wanting to happen. I pulled out the negative because he was in my way and I needed it to be x squared minus, okay, so pull out the negative. The negative x squared becomes a positive. The positive 4x becomes a negative. I'm going to fill the blank. That blank is a negative number, so I add it on the other side to keep it balanced. Who's going to fill that square? If you need to, you can think of it this way and say I have an x squared. I need it to be squared, so if I cut that in half, I can keep it all nice and even as far as my dimensions. What's going to fill it? I have an x and a minus 2. I have an x and a minus 2. What's going to complete the square? 4. And so a negative 4 and a positive 4. I can then go ahead and factor that guy to be the integral of, well actually, if it's a negative this with a plus and a 4, I can rewrite that to be 4 minus, and then if I factor that, it's x minus 2 quantity squared. It's a perfect square with x minus 2. What does this look an awful lot like? I believe it looks like arctangent. Who's my A?
2.
Square root it, good. Who's my du? Remember, the board's on Friday. Take the derivative. What's the derivative of x minus 2?
1.
So therefore I can rewrite this to be the exact same thing as 1 over square root of a squared minus u squared du. Who does that go back to? Not tan. Not arctan. Who has a square root with no messiness in the front? Not arcsecant. He has the messiness in the front. And he's a u squared minus an a squared. Who's the a squared minus the u squared? Poor sine, so easily forgotten. This is the definition of tricky with arctangent, or arctrig. The definition of tricky with arctrig. Most of the numerator is just a good old-fashioned u sub. A good old-fashioned u sub with this as its u. That's going to be u to the negative 1/2. Plugging in a negative with a du, which is going to get me to negative add, which will make it with a 1/2 power. Multiply by the reciprocal, which would be a 2 over 1. Throw in your u, which is 4x minus x squared plus, but this poor little other guy, to make it possible to have that be u sub, I need to go ahead and have the minus 1 that makes that perfect and the plus 1 that's a zone deal. That led me to an arcsine, and I believe, That's all you need. Oh, wait a minute, but what are you supposed to do with that, guys? Why is it saying round? Because what kind of integral is it? Definite integral. So now that you've gotten down to here, the final job is to go ahead and plug in the 1 and plug in the 3 and simplify. Boop. Okay, that was me helping on number 12. Let me freeze the screen for just a bit. Maybe a few of you guys are trying to plug in a 3 and plug in a 1. Remember, 1/2 power. Can't that be rewritten to be something easier? What is the 1/2 power? Yeah, it's the same thing as just a good old-fashioned square root. So if you want, you can put the square root instead. That works. But let me freeze the screen because I'm going to also pull up CalcAB. And also pull up CalcAB to see if you guys had anything that you wanted to check out or wanted me to check out. On con, there's AB, there's AB. Whew. To be honest, Andy, I was looking like way down the line. Like I did that way earlier than you guys probably would have normally done it. It probably would have been best for you to notice that it was arc trig because I didn't have any other U sub ways of doing it. Arc trig is the one that like you don't have anything to do U sub with. So then I went ahead and I pulled out a negative sign to get x squared minus 4x. And then I said like, hey, this is almost like a complete the square thing. So remember that you take this middle term and he needs to be evenly distributed for it to be a perfect square trinomial. So we always take that and we always cut it in half. When we cut it in half, we have the possibility of it being a square, being the same thing on both sides. So I took that negative 4x, I cut it in half. I noticed it was going to be a negative 2x, and so I knew what I was aiming for. I was aiming for an x minus 2 from the half of that guy. In the olden days, we would have said something like, to complete the square, I always do b, and I cut it in half, and I square it. In the olden days, we'd write a little formula out for complete the square. That's another way of looking at it. And so once I took that and I split it evenly, and once I realized what I wanted, then I made it happen by negative 2 times negative 2 is positive 4, so I completed the square, I added, and I offset, because that's a negative 4 in all reality. So I needed to do the opposite of it with the positive. Then I rewrote it to look like this, and then you can finally see why I said that so long ago. Because it's a squared minus u squared. So u was the guy on the inside. But it depends as you get practice. And not that this is like all over the place in the AP, it's not. But it's just one of the typical arc trig things that happens. It's like, well, we're showing you the simplified form, but it could have come from something that was a little bit messier, but easier for your rule. So we spread it out. We kind of like bring back the mess so we can see everything clearly with the a squared and the u squared. And I went from there. But Andy, how I saw it is I just took half of negative 4. And I knew it was x minus 2. As a result of minus 2 being half of negative 4. But where you could probably see it a lot better is down here. Did anybody back up Victor on that 1 point whatever it was?
Yeah.
And what was it one more time? 1 point what?
1.047.
And that'll happen after you plug in and get like the square root of 3. You also are going to have like arc sine of 1/2, which sine is 1/2 at pi over 6. So you would have had a pi over 6 in there. You would have had a negative 1/2, so a negative pi over 6. Oh, those might have canceled. No, I think they would have combined. but there would have been quite a bit of math to get that decimal, but the calculator would have backed you up on it as far as from the very beginning. Kiddos, I don't need that, that's not you guys. I do have Khan Academy up. There was the article that you were just reading through. How to get out of order? I don't even know. There was the article that you were reading through and seeing if you can just do a couple problems on your own. Then there were like different problem sets. I mean, the first one I didn't mean, or I should say all of them. I didn't mean for all of them to be as tricky as others. In some ways, like you were just trying to say what it meant. You weren't even having to solve. In some other ones, you were actually having to solve, but you weren't actually having to get decimals or anything. You were just trying to answer like what exactly is going on. I think I have the interpret. I think I have the problems and the analyze. My goal was interpret, analyze, then problems. But for some reason it got out of order, and I can't change the order once it's in Khan, which is kind of annoying. But did anybody have anything about the interpreting or the analyzing or the problems that they wanted to ask? Yeah.
We didn't have to get 100%. Right?
No, you didn't have to get 100%. Just make your way through it once.
And some of them, like, I didn't really understand how to do it besides, like, a calculator, so is that okay, too?
Oh, for how to, like, go all the way?
Yeah.
Yeah, that's okay. Because these ones will normally be application problems like you saw on the Jamboard with the water flowing. Yeah, that's okay. That's okay. Okay, then I'm here and I'm available for individual questions. I mean,
From 0 to 1 over root 2 of arc sine x over root 1 minus x squared.
if you guys want number 10, this is a great one that people have been bringing up after school, but no one in class has been asking me questions. There is a way to choose U. There is a strategy for choosing tricky U's. Not normal U's, but tricky U's. If you ever see a logarithm inside an integral, a logarithm, or if you ever see inverse trig inside an integral, or technically there's a whole acronym as far as liate, a way of choosing U, tricky U's. If you see an ln, you make that U. If you see inverse trig, you make that U. What do I mean? You make this U. You'd have to go back to your forever cards like we did on Friday to see what is the derivative of arc sine. But as soon as you reminded yourself again, because we did it on Friday as well, what this looks like, you're like, oh, that's that guy. Now, if you follow the system of what we do by getting dx by itself, you could follow the system, and then you could plug in for dx and make that substitution. But what you would end up with is a u over all of this stuff times this guy. It just goes away. The du accounts for it. There is no need to integrate that. All I'm integrating is u, which would be 1/2 u squared. But applying that to my definite integral, I would have 1/2 arc sine squared from 0 to 1 over rad 2, which is the same thing as rad 2 over 2, if you like him in his simplified form. Which would be the same thing as 1/2 times arc sine of rad 2 over 2, which you should be hearing bells of pi over 4 going off in your head, minus arc sine of 0. Where is sine this guy? Is pi over 4, which would lead to pi squared over 16. Where is sine 0? That would be 0, which squared is still just 0. And I would end up, I believe, Hovan, with pi squared over 32. But I did do that pretty fast. But if you have a weird integral, think Liate and be like, is there a logarithm? You're you. Is there inverse trig? You're you. I heard a question for you. Oh, no, not 5.1. I'll go fix it. No.